degree of an array. So to solve this problem, we need to have an understanding of optimizing lookup, because this question is all about optimizing the lookup of the count and optimizing the lookup of the length of the subarray. So you always want to optimize lookup with hash tables. The point of hashing is so that you can have O1 lookup. And O1 lookup is very important, especially for questions like this where lookup is, the operation that needs to be optimized. So with this understanding, let's try to apply it to this problem. So using this example, right, we have the array to be 1, 2, 2, 3, 1. The output is 2, given the explanation below. So there's really two steps to it, right? The first step, and I'll zoom out a bit, the first step is really to get the count of the most frequent number. And in this case, the count is 2, because we can see here we have two 2's in the array. So after you get the count, you have to then be able to see what is the smallest length of the subarray. And you immediately see that from the examples, the optimal solution always is where you start and finish with the number with the largest count. So the optimal size will be 2, 2, or 1, 1. And you have to basically keep track of how many times each number appears, but also where each of the first and last occurrences of a given number occur. So in this case for 2, right, and we have a table, the start and the end, the starting position will be 1, the ending position will be 2, and for the number 1, the starting position will be 0, the ending position will be 4. And therefore, the length is going to be 4, the length is going to be 1, 2 minus 1, so, or 2 minus 1 plus 1, so this length is 2, the length is 5. So that means the smaller of the subarrays would be the one with 2's rather than 1's. So you see we need to keep track of 3 data points. The first point is frequency, the second point is the starting points, the third is the ending points. And we then basically see which end minus start plus 1 gives us the smallest length for a given frequency that's the most frequent, and we solve the problem like so. And we can translate this now into Python. So from the logic, we need to keep track of 3 things: the count, the starting position, and the ending position. So going with our logic, for I in range 0 to length of nums. Now I do this because I also need to keep track of the positions, which are indices. We're going to say if nums I not in count, meaning we've never encountered this element before, then we simply say count of nums I is equal to 1. We increment it by 1. And we also say else, meaning we've seen it before, count of nums I plus equal to 1. And now we have to also update the start and ending positions. If nums I not in the start dictionary, then we have to say start of nums I is equal to I, and we also populate the ending position, and you will see why in a bit. But otherwise, we're going to say, otherwise, it's going to be end of nums I is equal to I. Now, the reason why we also populate the end variable, or end dictionary, is because we want to account for the case where an element only occurs once. So consider this example. 3 only occurs once. So it starts and ends on the same index, which in this case is 3, which is accounted for when we populate the end with the start. Now, we populate the start in the else statement so that we always get the most last occurrence position of a repeated value. So that's it for this for loop. Now we want to know the result, right? The result is going to start by the length of the array, and we're going to say for I in count if, and we also need to know the degree, so the degree of the array is equal to the max of count.values. So if count of I, remember this gives us all the keys in count, if this is equal to degree, then we have to say we want the res to be the min of the current result with the length of the subarray, which is counted or calculated by end of I minus the starting position plus 1, because it's inclusive of the endpoint. And then we just return res, and we should be good to go. So let's run it. And we pass, so let's submit. And we got accepted. So that's the solution.